Random variables. A random variable is a variable whose value is a numeric outcome of a random phenomenon. It assigns one and only one numerical value to each point in the sample space for a random experiment. A discrete random variable is one that can assume a countable number of possible values. A continuous random variable can assume any value within an interval on the number line. We will be working with discrete random variables in this section. A probability distribution table of a random variable x consists of all possible values of a discrete random variable with their corresponding probabilities. Example: suppose a family has 3 children. What are the gender combinations if we disregard birth order? Well, we could have 3 girls, or we could have 3 boys, or we could have 2 girls and a boy, or lastly, 2 boys and a girl. Now, what if we do worry about our birth order? How many different birth order arrangements do we have with respect to gender? Well, 3 girls, or 3 boys again. Now with the 2 girls and 1 boy, those 2 girls can be born first and then the boy would be the 3rd child. Or we could have a girl, then a boy, then a girl. Or the boy could be the eldest and then the 2 girls. With the 2 boys and a girl, boys could be born first, then the girl. Or we could have boy, girl, boy. Or we could have girl, boy, boy. This gives us a total of 8 possible arrangements. Notice that this is 2 to the 3rd. Since we can have a girl or a boy, we have 2 different choices. When we're worried about the arrangements, it would be, since we can repeat the gender, 2 times 2 times 2. Now, a probability distribution for this example would be drawn like so. We'll make a line. We indicate our random variable and then the probability that x is equal to that random variable value. So x equals x sub I. So I want to make a probability distribution for just the number of girls in the family. Well, we can have no girls, 1 girl, 2 girls, or 3 girls in a 3-children family. With 8 possible outcomes, only one of them, the one with 3 boys, has 0 girls. So the probability of having 0 girls is 1/8. Now with 1 girl in the family, we have 1, 2, 3 different possibilities from our arrangements. So that would be 3 out of 8. 2 girls also has 3 different arrangements. 1, 2, 3. And there's only one way to have 3 girls. And once we've organized our random variable into a probability distribution like this, we can answer probability questions such as part D. Find the probability that x is greater than or equal to 2. Pay close attention with these discrete random variables about whether or not we have the or equal to symbol. So what this means in our situation is that we have either 2 girls or we will have 3 girls. Now, since we can't have both 2 and 3 girls, we'll find these probabilities by adding. So 2 girls was 3/8. 3 girls had a probability of 1/8. So the probability that x is greater than or equal to 2 is 4/8 or 1/2. Suppose I want to find the mean of a random variable. If I have its probability distribution, then the mean or expected value of that random variable x is found by this formula. Mu sub x equals, and we could also call it E of x, x1 times its probability plus x2 times its probability plus and so forth and so on through our last value of x. The variance of a random variable can be found using the formula x value minus mean squared times the probability. We add all those up, and that's the variance. There's a shortcut formula. The variance of our random variable is the expected value or mean of the x squared values minus the square of the expected value, the square of our mean. We're going to use the second formula on our next example. Recall that if you're asked for the standard deviation, it is the square root of the variance. So let's use our probability distribution from example 1 and find the expected number of girls in the family and the standard deviation for the number of girls. Recall that we could have 0, 1, 2, or 3 girls in the family. The probability of no girls was 1 out of 8, 1/8. 1 girl had a probability of occurring 3/8 of the time. 2 girls was also 3/8, and 3 girls happened just once out of 8 times. The expected number of girls, or the mean number of girls for this random variable, would be found by 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. And this would add up to be 12/8 or 3/2, or rather 1.5. So on average we'd expect 1.5 girls. Now before I can get the standard deviation, I need to get the variance. I'm going to use the formula for the variance. Of expected number of the x squareds minus the expected value of x all squared. Well, this value right here is the 1.5 that I just found, so I'm going to plug that in there. But how do I get the expected value of x squared? Well, let's add on to our chart x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So the expected value of x squared would be 0 times 1/8 plus 1 times 3/8 plus 4 times 3/8 plus 9 times 1/8. And what that gives me is 24/8 or 3. So my variance would be 3 minus 1.5 squared, which is 3/4. The standard deviation would be the square root of this variance, which would be square root of 3 over 2. Use the probability distribution to find the following. Well, our first question is asking for the probability that x equals 4, and that's blank. So we need to figure that out from our given information. Recall from the probability rules that the sum of all probabilities within our sample space should be 1. So if I add up every single one of these values and subtract them from 1, that's going to give me the probability of 0.4. And that leaves me with 1 minus 0.7, which will be 0.3. So let's add that in our table. Now the probability that x is less than 2, less than does not include 2, so that would be the same thing as asking for the probability that x is 1, which is 0.15. The probability that x is between 2 and 5, not including the 2, we are including the 5. This would be the same answer if I had x greater than or equal to 3 and less than or equal to 5. Or rather, the probability that x is 3 or 4 or 5. So I'm going to add those up. And that's going to give me 0.5. We had 0.1 plus 0.3 plus 0.1. Now the probability that x is greater than or equal to 3 would be the probability of 3, 4, 5, 6, and 7. Notice it's a lot shorter if I figured out the probability of 1 and 2 and subtracted that from 1. So notice this is the same thing as 1 minus the probability that x is strictly less than 3, or rather 1 minus the probability that x is 1 or x is 2. And that leaves me with 1 minus 0.2, which will be 0.8. The expected value for x will be 1 times 0.15 plus 2 times 0.05 plus 3 times 0.1, 4 times 0.3, 5 times 0.1, 6 times 0.15 plus 7 times 0.15, and that comes out to be 4.2. Now to get the variance, I need to list my x squared values. So I'm squaring every value for x. And I'm going to multiply each of these times the corresponding probabilities and add those up. And that will be my expected value for x squared. So we're going to have 1 times 0.15 plus 4 times 0.05 plus 3 times 0.1, 9 times 0.1, 16 times 0.3, 25 times 0.1, 36 times 0.15, and 49 times 0.15. Then we will subtract from that our expected value of x squared. And this gives me 3.66. The standard deviation will be the square root of 3.66, which is approximately 1.91. Now suppose x is a random variable and we define a new variable w such that w is a linear combination of x with some real value. So a times x plus b. For example, 3 times x plus 1. The mean and variance can be found without recomputing all of my probabilities and values. The mean of a linear combination of x, the mean of a times x plus b, is a times the mean of our original variable x plus b. The variance, however, ignores the plus b. Remember, variance measures spread. And if we just add a value to everything, we are only shifting everything over by that much, which will not change how our values are spread out. So only the coefficient of our variable will matter. And since the variance is created with squared terms, then the new variance is a squared times the original variance. Likewise, if we have two different random variables, x and y, the means and variances of combinations of them can be found with these formulas. The mean of x plus y is the same as the mean of x plus the mean of y, and the variance of x plus y is the same as the variance of x plus the variance of y. However, if I'm subtracting, no surprise with our means, the mean of x minus y is equal to the mean of x minus the mean of y. But the variances, the minus becomes a plus. Again, we're squaring everything. So when we square that negative 1 that's in front of the y, it becomes a positive. Example 4. Suppose you have a distribution x whose mean is 22 and standard deviation is 3. Note that this is the standard deviation, so its variance would be 9. Now define y to be 3 times x plus 1. The mean or expected value of y is equal to the expected value of 3x plus 1, as defined right there. So that'll be 3 times the expected value of x plus 1, or 3 times 22 plus 1. Now the variance of y will be 3 squared, or 9, times the variance of x. So 9 times 9 is 81. The standard deviation of y will be the square root of 81, which is 9. Note that the standard deviation, since it's the square root of the variance, so the standard deviation of a times x plus b is just a times the standard deviation of x. So for this problem, 3 times 3.